I've spent, most of my career in enterprise IT. So understand the pain points and all that. And actually, this is a great place to ask a question. How many folks in the room would consider themselves enterprise IT, let's say 10,000 or more? So pretty good collection of large scale, bigger than 10,000. Joe, I know yours, you're gonna keep raising your hand, so you don't worry about it. Yeah, okay, so some large organizations here, which is the stuff that a lot of us have really spent a lot of time in. So the agenda of what I'm going to cover today is sort of in 3 sections. Talking a little bit about passwords. I won't belabor passwords too much with you, except to talk a little bit about research. Everybody in this room knows passwords suck, not to put too fine a point on it, and we spend most of our lives engineering our way around it or trying to survive it. Then diving into Azure AD Password Protection, and then at the tail end, some references. And I've cut out some slides because due to length, but I'll make sure that the full slide deck is available for afterwards. So passwords and password spray. We could spend a whole session talking about this, which are somebody earlier asked this question of Brian, which are the updated password guidelines that have come out from NIST and also from Microsoft as well. Talking about what real research and what real experience in large-scale cloud computing is shown about credential attacks and what works and what doesn't work. In a nutshell, the recommendations are don't expire passwords, don't enforce complexity, require a minimum of 8 characters but allow at least 64 character passwords, including spaces and Unicode characters. Now, if someone can tell me how to enter a smiley face emoji as a password character, I would like to know how to do that because I haven't quite achieved that one yet. And this one is somewhat controversial. Don't change passwords after compromise. And the last is to ban common passwords. Now, generally, these are recommended more or less as a set. In other words, if you're going to do some of these, you should be doing most of these. Again, the change passwords after compromise, people have really strong feelings about it. And password policies are among the most sacred cows in security. It's very, very hard to get this sort of thing to change. Microsoft, to their credit, they have a lot to lose by not getting it right, has been adopting these very strongly. But it's understood that we all have very complicated situations at home. However, of these to accomplish and of these to get through security approval, and maybe it's y'all, is the ability to ban common passwords. So, as I say, wide agreement on this. This is not one of the more controversial ones. It's pretty clear. Banned passwords, or common passwords, are the first to be compromised. Back in April, NCSC, which is the UK's National Cybersecurity Center, released the top 100,000 most common passwords from Have I Been Owned. And they found 23 million times. Most, and of course, this means that people aren't checking against it. The services or the applications aren't checking against it. Some of the cloud services are, most of them aren't. I think it's kind of interesting to explore what some of these passwords have on here. So we have the ones you expect: password 1. We have I love you, which I wouldn't have expected. There's another one on here, homeless spa. That's like number 24. Tinkle. And the last one here, which I'll be good, and if you can read it, it's basically, it's basically doing that, which shows what people feel of having to enter those passwords.
That's probably the password that he entered after the 6th time through the password.
Complexity filter. Right, which brings us back to the password complexity. So let's talk about password spray for a second. which I call brute force upside down. Obviously, this is an attack that is aimed at common passwords. And I call it a brute force upside down because in a brute force attack, you're aiming at one account and you're hammering it with a bunch of different passwords. Whereas in password spray, you're taking a common password and you're touching a whole bunch of different accounts. And you may not do it in a brute force method. You may not hammer it. Typically, a password spray attack happens at a low enough frequency that it doesn't trigger alarms, at least of smaller services. The big services like Microsoft Cloud does correlation across IP addresses and everything else to surface these password spray attacks. They're much harder to detect, as I said. Sometimes, and I'll show a statistic for this, it takes up to 6 hours per attempt in between them, or more, sometimes days. Azure AD blocked 200,000 password spray attacks about a year ago in August, and you know that frequency has risen dramatically. This is a graph from Microsoft, and what it shows are several password spray attacks and their distribution. So this goes from June 18th to, I believe, June 21st. And each one of these, each color is a password spray attack with a certain password. So you can see over the first few days, this spray attack hit between 5,000 and 6,000 accounts, and then it disappeared for a few days, and then it came up at lower frequency. And these are all interleaving password spray attacks. So it's very, very hard to defend against a password spray attack. And of course, how many of you are, so actually a great question, how many of you here are like general info security people? How many of you are identity people, Active Directory people? Yay, okay, we got a bunch of AD folks. Okay, yes. So you know that AD is vulnerable to password spray. That really doesn't have an out-of-the-box defense against it, because password complexity doesn't understand, it can't block out simple passwords. And of course, we know from the statistics that your users are reusing their corporate password in their social media sites and everything else like that, and vice versa. So they're trying to make their life easier, so you know you're getting credential reuse, which is so dangerous. Now, there are some third-party password filters that do provide common password detection, like Enzoic, but there are not that many. And it's typically been a hard problem to solve. Do many of you folks have any kind of third-party password filters or do any kind of password protection right now? So a couple. So it remains a big vulnerability. So what is Azure AD Password Protection? In a one-slide nutshell, this is what it does. So it provides you common password analysis and rejection for Active Directory, not just Azure Active Directory. So the name is a little bit of a misnomer because it's a hybrid service. So of course, Microsoft is, whenever they can possibly do it, they're labeling something Azure AD rather than Active Directory. So it's a two-part service. It's got stuff in the cloud and it's got stuff on premises. What the service does is it builds a banned password list, which is collected and built from the Microsoft Intelligent Security Graph, Alex Weinert's team of Microsoft Cloud Identity Security. And that forms a backbone of about 1,000 passwords. It's culled out of 6.5 trillion signals that the Microsoft Cloud collects per day, whether it's user logins, re-authentication, endpoints, Xbox, all of this stuff, to come up with common passwords, specifically passwords in their quote, actively being used for attacks. There are plenty of common passwords out there. They're not putting them in the banned password list if they're not currently seeing them. It's a very elegant architecture, as you'll see shortly. It doesn't require the domain controllers have any internet connectivity. It barely requires any corporate network internet connectivity. It doesn't unduly load the DC. It uses the standard authentication LSASS. It fits inside LSASS with a password filter. So everything, it's a minimum of interference with what's out there. And early adopters found that it blocked between 20% and 50% of attempted passwords as too common. So from the security point of view, that's great. From the help desk point of view, buckle your seatbelts. And the licensing, always the great licensing discussion. This is actually a nice thing. So the way Azure AD Password Protection is licensed is that as long as any of your synchronized users between on-prem through AD Connect up into Azure AD are licensed for Azure AD P1, every user in your connected forest is licensed for Azure AD Password Protection. So if Joe back there decides to get a P1 license for himself, and then he can then license all of his corporate forest in his massive company to use password protection. So the licensing is pretty liberal. So what does this thing look like? And I think I'm going to have to modify my slides section here a little bit. Okay, good. Hello. So this is an overview of what this looks like, and I'll break it out into 3 sections. So this section up here is the Azure Active Directory part of it. This is the cloud part of the service. Over here is the on-premises part, the corporate network. So you can see here you've got a domain controller, you've got another domain controller, and this has agents on it that I'll dive into in a second. And then in between it is a proxy service that handles policy and password list request and return. So on-prem, in the cloud, domain controllers, and proxies. So the Azure AD portion contains the basic service settings. Turn it on, turn it off. One thing that Azure AD Password Protection gives you is the ability to create a custom banned password list. So there's a global banned password list of about 1,000 accounts that you can't touch, but you can build a custom banned password list that is particularly appropriate to your business or your industry or your vertical. That, say you work for an auto company and users may tend to use the company name as a password. You can add that to the banned password list and say, no, you can't do that. And also smart lockout settings, which are, I won't really go into much here. Essentially, smart lockout settings are when a user is logging in through Azure AD and they're locked out due to a bad password, it will lock them out for a certain period of time, unlock them, and if they enter bad passwords again, the lock time increases and increases, kind of like you see on like an iPhone. Now, Azure AD has banned common passwords for a while. And I was going to pull something up here. Let's take a look. Since this is an identity crew, have any of you guys heard of, guys, I'm using it as gender neutral. Are you familiar with the Brave browser? How many of you have ever heard of the Brave browser? Few people. So this is something worth looking into. So the Brave browser is based on the Chromium open source platform, just like Chrome is, just like Edge is now. But it's focused on privacy for its users. It was written, the head of Brave was the head of the Mozilla Foundation, and he was the guy that wrote one of the, I can't remember which major programming language is for web programming, Gil probably remembers. But bottom line is, it's really highly designed for privacy. So to give you, this is my little public service announcement. So if I open a new page in Brave, this will tell me that it has blocked 124,854 ads and trackers It's automatically upgraded 273 sites to HTTPS, and it's estimated it saved me an hour and a half without going out, all of that stuff. And that is since August, mid-August. So, I highly recommend it. So what I was going to do, though, is let me fire up a private window. And by the way, Brave also allows you to fire up a Tor window right within the browser itself. It's just another option. So you don't have to do all the other Tor stuff. So what I'm going to do is I'm going to log into portal.office.com. And that's going to prompt me to sign in, and me being essentially lazy and short on time, I'm going to copy this account and paste. So this is a cloud user in my hybrid identity net hybrid network, and it's Mulo0464. So yeah, well, that's the initial password that it gave me, and I've never changed it because I just do this. So okay, so current password, and I'll give a new password, and I'll come up with something unique like P at SSW0RD1. I'm sure you've never heard that one before. P at SSW0RD1. Dun-dun-dun. And it tells you, we've seen that password too many times before. Choose something harder to guess. Yeah, that was a capital P. Darn it, that machine learning. So that's what it looks like in Azure AD. I'm sorry, that's what it looks like logging onto it. Now, if I go look at it, and so this is my environment. And let's go down to, this is aad.portal.azure.com. They just moved this the other day. That's what this little pink thing says. And so now at password protection is under security, authentication methods, password protection. So what we have up here, here's the smart lockout. Lockout threshold 10 times. Lockout duration, 60 seconds, then it will increase if you keep muffing the password. Here is the custom band password list. And what I've done is I've entered Ford, General Motors, Chrysler, Tesla, Mercedes-Benz in there. In other words, in addition to the common band passwords, you can't enter these either. Those will be rejected as passwords and variations thereof. By default, this is turned on, which gives you a little bit of pause. But once you realize, usually it's, by default it's turned on, it's in audit mode. So that it will pass everything. Users, once you have it fully deployed, users will still be able to enter anything that they want to, but the event logs will show where they would have been prevented or where it would have failed password protection. And then you can turn it on when you're ready to enforce it. Sure.
So what event would you turn audit on when you're just trying to build a list of, custom passwords? So you see the organization is using these passwords. All right, now I'm going to enforce it. I'm going to put those passwords right into the main password.
Well, it doesn't actually show you the passwords that they entered. Oh, I'm sorry. The question is, if I got it correctly, can you use this to build your custom password list, the evidence of the passwords that is going? And the answer is it doesn't show you the exact passwords they use. It just simply says this would have failed if you had had it in enforcement mode. So the proxy service. The purpose of the proxy service is what proxy services do. It allows domain controllers to get the banned password list from Azure AD without requiring they have internet connectivity. So what it will do is the domain controllers request the banned password list from Azure AD, but they do it via a proxy. So it acts as a forwarding service. So it forwards a request up to Azure AD, please give me the banned password list, and then when it gets the banned password list, it forwards it down to the DC that requested it. You can put the proxy service on any domain join server because you want fault tolerance. You should deploy it on 2 or more servers. Your Azure AD Connect server, for example, is a good sample for it, or maybe an app proxy server or anything like that. It's pretty lightweight. It doesn't do a lot of stuff. You get the bits in the download center. It requires .NET 4.7, and there's a registration process that takes place where with PowerShell you have to register both the proxy service with Azure AD. That requires global admin rights once to register the service. And then you have to register the forest with Azure AD, and that requires domain admin rights. Once you've done it once, you never have to do it again. Even if you remove the components for password protection and put them back in, you don't have to register it with Azure AD again. So let's take a look at what the proxy configuration looks like. There's not a lot to see, but that's okay. So this is, zoom in. So here the service is running. It's called Azure AD Password Protection Proxy, and it has a nice little description of what it does. And if I go down to the event log, if you want to monitor the activity that's going on, bless you. That's not what I had intended at all. Let me pull this down. So up at the top, this is under applications, all the way down to Microsoft. You can see all the fun stuff. Azure AD Password Protection, Proxy Service, Operational. And so let's slide over and take a look, for example, a typical event that we'll see here. Azure AD Password. The Azure AD Password Proxy Service forwarded a message to Azure on behalf of the calling domain controller and received a successful response. That's pretty much all you're going to see on the proxy. Now, the DC agent and the password filter, that's where things get a little bit more interesting. So the password filter, your AD people, you know what a password filter is. You know, you're intercepting this password request and running it through whatever it is that you choose to run it through, like passfilter.dll. This is a very, very thin password filter. All it does is forward the request to the DC agent outside LSASS. It does work with other password filters, so if you've got something, another password filter on, it works in an AND operation. So it has to pass all the password filters, have to return true before it allows the password change. And because it is within LSASS and it is a password filter since the dawn of time, or at least 20 years ago, you have to reboot the domain controller, which is something that you have to think about in terms of deployment as well. Obviously, it has an impact on your production environment. The DC agent, that's the heart of the system, and it performs password evaluation, and it also handles the policy that it gets down from Azure AD, you know, munches it around and does stuff. So here's the password filter as part of LSASS. Password validation request goes to the DC agent. So it does the evaluation, and it also takes the policy, reformulates it, it takes the list, puts it in a policy, and drops the policy on sysvol. So how does that work? So the DC agent checks for a current policy on sysvol. Is there any policy at all on sysvol? Again, this is very, very, very lightweight. One domain controller per site per hour will check the policy, and if it determines the policy is expired, I'm not sure what the expiration timeout is, but it's checking every hour. I look at this list as important but not urgent replication. Banned passwords and common passwords don't change that often and that quickly that more than once an hour or a few hours is going to be fine. So all the domains in the forest do this. 1 DC per site per hour says, do I have the current password policy? If not, it requests it from the proxy server. When it gets it from the proxy server, it actually creates the policy and then writes it to sysvol. And the beauty of sysvol, of course, is then it replicates it to all the other domain controllers. So all you have to have is one domain. You can have a lockdown AD forest, and all you have to have is one domain controller that can see one proxy somewhere that can then see the internet, and you'll be able to apply this. Which is what I just said. And this is just a graph of, a flow chart of what it does. So on validation, it's pretty straightforward. The user contacts the DC to reset their password. It goes from the password filter to the DC agent. The DC agent evaluates the request and approves or rejects it, and the success or failure is returned to the user by the usual method. Now, there's an interesting part about this to be aware of. Because this is all done within the normal Windows security model, the user is only going to get the same rejection message they have always ever gotten. I'm sorry, this does not meet password complexity requirements, blah, blah, blah. Even though what they may have entered yesterday in their lousy common password would have worked. So you have to be aware of that, and there has to be some user education involved because the behavior may change. So when the password is actually evaluated, what happens? So the first thing that happens is normalization. In other words, all the uppercase letters are changed to lowercase, and the character substitutions are thrown out. Yes, I hate to break this to you and your parents and your aunt and uncle, but putting a $$ up there is not going to confuse anyone anymore. So we have it all lowercase and then all the character substitutions removed. The next thing that happens is a fuzzy match. And by fuzzy match, it means if you have entered a password like this, a common password, or what you're trying to enter contains this, at an edit distance of 1 means that if you put a G onto it, no, that's not going to float. Just the fact that you put a G onto it is not going to make it any better. Or if you have here and you drop it off by 1 or 2 or 3 like that, it's still, if you remove it and you have 1 less, that's still not going to pass. In other words, you've got to do a better job than that. And now they've adjusted this algorithm somewhat because it was a lot of people complained in the beginning. So it's always that tension between security and usability. And finally is the fine-grained evaluation. So this is done on a point score basis. For this example, the password that's being attempted is Detroit 2019 ASDF J236. Pretty long. So what it does is this. First is it finds the common password substrings in here. In other words, Detroit 2019 ASDF. Every common password substring gets 1 point each. So that means for this particular password, we've added up to 3 points. 1, 2, 3. After that, every character gets 1 point each. So J236, 1, 2, 3, 4. So what we have is 3 and 4 is 7 points, and so it passes, and this password would be allowed. Now, Microsoft reserves the right to change this without notice, of course, because if we know it, bad actors know it as well. But this is designed really to protect users against themselves. Any questions on how that evaluation goes? Make sense? Okay. So let's take a look at what this actually looks like. This is my domain controller, and let's take a look and show you what the service looks like first. Not a lot to see, runs as local system. Explanation of it, not a big deal. Azure AD Password Protection, DC agent. If I look at this in the logs, well, actually, let's work on a change. So I've got a command prompt here, and let's see. Let's do a net user 2, and let's set that password again. P@SSW0RD1, and it's a domain account. And the error is the password does not meet the password policy requirements. Check the minimum password length, password complexity, and password history requirements. Doesn't say common passwords in this. Again, it's the operating system rejecting it. And I could show you from a client, but it's basically saying the same thing. So that's an example of the common banned password list, the Microsoft generated banned password list. Let's try the custom banned password list. Same issue, same result. Can't do that. Well, let's maybe add a 1 onto it. Nope, that's that edit length thing again. So, and obviously, and then you can expand it and go beyond that. Now, if I go look at, for monitoring what this is doing, and I'm looking at the service, I'm looking at this in the event logs. So this is in Applications and Service Logs, Microsoft, Azure AD Password Protection, DC Agent, Admin. The other one was operational. This one is Admin. And these are informational messages. And this particular one says, the reset password for the specified user was rejected because it did not comply with the current Azure password policy. Please see the correlated event log message for more details. So it will say the user name, but it won't say the exact password that was used. This is actually a pretty useful message from an administrator's point of view. Unfortunately, it's hard to get that out to a user. So that's pretty much it. It's a straightforward architecture. It's very flexible. The deployment is very flexible. You can deploy the proxy agent first. You can deploy the DC agents whenever you want to do. When you put it in place, it will come on. Note that for full coverage, you have to put this on all of the domain controllers. I mean, you guys are AD people. You have to put it on all the domain controllers, so if somebody authenticates against the DC that this is not on, they'll slip through the cracks. Now, a recommended practice perhaps you can do is to install it on all the domain controllers for a given site, and then turn it on, and then the users in that data center or that location will experience it, which will give you a little sort of a pilot for it. But to be effective, it has to be on all of them. And as I said, this is one aspect of all of that. You know the drumbeat on this. MFA, other password weaknesses, risk policies, block legacy authentication. It's a whole suite of things that has to happen. So that's it. Any questions about password protection or anything else? Any hard questions I can throw to Gil or to Joe or anyone else like that? I'm really good at deflecting. Yes?
Is it possible at all for administrators to get a kind of record of the most commonly rejected passwords or something?
So the question is it possible for administrators to get a report of the most commonly rejected passwords? And no, they don't. It doesn't reveal the passwords to that level. It's rejected. Yeah, right at the level. Well, I will bring that back because I'm sure people want to be able to. You want to be able to fine tune your own custom banned password list rather than just making a scientific wild ass guess. I mean, did I say that? A scientific guess about it. Yes.
Are the minimum requirements for enabling audit mode then simply to have identify one domain controller in a site and then have an agent system set up in the environment?
The question is, what is the minimum that you need to do to be able to peek at the service? Is that what you're saying? Yeah, if I wanted to deploy this minimally to see what it did, I would find a branch office site that has one domain controller in it, install it on that domain controller, and watch the audit logs on that DC. And then spread it out from there. And as I said, user education is very important on this too, because the lack of fine-grained guidance on what's not working. Okay, thank you. Appreciate it. Thanks for staying awake.